Okay. The PPT is visible, right? Everyone. Okay. So as you can see, people have joined the class. So I'm going to start the session right away. It's already 5. Okay. So good evening, everyone. This is the 10th live discussion session of the course Soil Mechanics Geotechnical Engineering 1. And the topic of today's discussion is earth pressure theory. Uh, like the previous classes and like the regular classes, I'll be first discussing some questions. I'll be first dictating some questions with respect to this chapter. These questions will comprise of MCQs, MSQs, and numericals and true false, everything. So after dictating all the questions, I'll give you some time to write, and then after some time, after a break, I will start discussing the uh, discussing all the solutions and explain the concepts behind the solutions. Clear? So all you need to do right now is first of all write down the questions along with the options, and be ready with your calculator, pen and copy. I'll give you some time after I discuss all the questions, dictate all the questions. You'll then solve those questions. Okay. All right. So I guess I can start discussing the questions now. Okay. Earth pressure theory 1, it has more of theory part and less of numerical part. Earth pressure theory 2, it will be more of conceptual and with more number of numericals. It will be in the next week, in the coming week. Okay. Okay. So I'll start. The first question is, if every point on a soil mass is on the verge of failure, the soil is said to be in. If every point on a soil mass is on the verge of failure, the soil is said to be in. Your options are elastic equilibrium, active state, plastic equilibrium, or none of these. I'll repeat the question once. If every point on a soil mass is on the verge of failure, the soil is said to be in. Soil is said to be in. Your options are elastic equilibrium, active state, plastic equilibrium, or none of these. Okay, next question. The ratio of the horizontal to the vertical stress in a soil mass is known as. The ratio of the horizontal to the vertical stress in a soil mass is known as. Your options are stress ratio, coefficient of earth pressure ratio, or none of these. What is that ratio called? You have to state the word, state the phrase. What is that ratio called? I'll repeat the question once. The ratio of the horizontal to the vertical stress in a soil mass is known as. The ratio of the horizontal to the vertical stress in a soil mass is known as. Your options are stress ratio, coefficient of earth pressure ratio, or none of these. Clear? I'll go to the next question now. When a retaining wall moves away from the backfill, the pressure developed is known as. When a retaining wall moves away from the backfill, the pressure developed is known as. Your options are active pressure, passive pressure, earth pressure at rest, or none of these. Kindly excuse me for a minute. Thank you. When a retaining wall moves away from the backfill, the pressure developed is known as. Your options are active pressure, passive pressure, earth pressure at rest, or none of these. Okay. Next question. Yes. Passive earth pressure occurs when the retaining wall is kind of similar to the last question. Passive earth pressure occurs when the retaining wall moves away from the soil, remains at rest, moves towards the soil, or none of these. You have to answer the condition of passive earth pressure. I repeat the question. Passive earth pressure occurs when the retaining wall, your options are, moves away from the soil. Here soil means the backfill, the backfill behind the retaining wall, that is the soil. So when it moves away from the soil or the backfill, when the retaining wall remains at rest, when the retaining wall moves towards the soil or towards the backfill, or none of these conditions. Okay. I'll go to the next question. with respect to the relative magnitudes of earth pressures. With respect to the relative magnitudes of earth pressures, you have to answer which among the statement is correct. Okay. Active earth pressure will be minimum. Active earth pressure will be minimum. Second option, passive earth pressure will be maximum. Second option is passive earth pressure will be maximum. Third option is both of the above. That is, both the first and second options are correct. Third option is both of the above. And the last option is none of these. None among these statements are correct. I'll repeat the question once. With respect to the relative magnitudes of earth pressures, the options are active earth pressure will be minimum, passive earth pressure will be maximum, sorry, passive will be maximum, active will be minimum, both of the above, that is both the statements are correct, or none of these. Okay, I'll go to the next question. Okay. Which among the following is considered while designing ordinary retaining walls? Which among the following is considered while designing ordinary retaining walls? Your options are active earth pressure, passive earth pressure at rest, or none of these. This is a question that is with respect to the application of the earth pressure theory. While designing ordinary retaining walls, which among these earth pressure are taken into consideration, or whether or not any of these are taken into consideration at all? Okay, that's also a question because none of these are also an option. So you have to answer which among these, that is active or passive or earth pressure at rest, or none of these. I repeat the question once. Which among the following is considered while designing ordinary retaining walls? The options are active earth pressure, passive earth pressure at rest, or none of these. Okay, I'll go to the next question. Which of the following is not an assumption in the Rankine's earth pressure theory? Which of the following is not an assumption in the Rankine's earth pressure theory? Your options are ground surface is planar, that is either horizontal or inclined. Option 2, soil is saturated and cohesive. Somebody has joined. Yes. Please write down the questions from the current question. I am currently dictating the questions. You write all the questions down. I'll give you some time. Then you will solve the questions, and after that break, I'll discuss the solutions. Okay. Whoever has joined, I'm just saying, please mute yourself. Okay. So second option is the soil is saturated and cohesive. The Third option is retaining wall back is smooth and vertical. It is the back of the retaining wall is smooth and vertical. And the fourth option is none of these. It means all the all the three assumptions are correct. Here I am asking about the incorrect assumption. This is not an assumption. Okay. I'll repeat the question once. Which of the following is not an assumption in the Rankine's earth pressure theory? Your options are ground surface is planar, horizontal or inclined. Option 2, soil is saturated and cohesive. Option 3, retaining wall back is smooth and vertical. Option 4, none of these. Yes, Amol Gambhire, you don't need to tell the answer, no need to tell the answers in the chat box. You solve it. I'll give you some time to solve it. Right now, just copy the questions and the solutions carefully. And after some time, I'll be discussing the answers. Then you can say, okay. And please mute yourself. I see you have not muted yourself. Please mute yourself. Okay. So, yes, you have to tell me which is not an assumption in the Rankine's earth pressure theory. Okay. Next question. Weep holes are provided in retaining walls for the following reason. Weep holes are provided in retaining walls for the following reason. Option 1, to improve the appearance. Option 2, to provide drainage of backfill. To provide drainage of backfill. Option 3, to avoid cracks due to shrinkage. And option 4, to avoid friction behind the wall. I'll repeat the question once. Weep holes are provided in retaining walls for the following reason. Option 1, to improve the appearance. Option 2, to provide drainage of backfill. Option 3, to avoid cracks due to shrinkage. And option 4, to avoid friction behind the wall. Okay. All right. Next question. For a cohesive backfill, the depth up to which the total net force will become zero is called. For a cohesive backfill, the depth up to which the total net force will become zero is called. Option 1 is critical height. Option 2 is unsupported vertical cut. Option 3 is both of these. Option 4, none of these. I'll repeat the question. For a cohesive backfill, the depth up to which the total net force will become zero is called option 1 critical height, option 2 unsupported vertical cut, option 3 both of these, and option 4 none of these. Okay, next question. In a soil, lateral pressure can never develop under this condition. Which of the following conditions will never develop or is the most unlikely to develop lateral pressure in a soil? Which among these conditions? The options are: option 1 is earthquake, option 2 is swelling, option 3 is ice formation, option 4 is over consolidation. I'll repeat the question. In a soil, lateral pressure can never develop or is the most unlikely to develop under this condition. Options are: option 1 is earthquake, option 2 is swelling, option 3 is ice formation, option 4 is over consolidation. Option 4 is over consolidation. Okay. Okay. Next question. The wall friction of the retaining wall. The wall friction of the retaining wall. You have to tell me what is the effect of the wall friction on the retaining wall. Option 1 decreases the active pressure but increases the passive pressure. Option 2 increases the active pressure but decreases the passive pressure. Option 3 decreases both the active and the passive pressures. Option 4 increases both the active and the passive pressures. Just a moment, I think I have lost my internet connection. I'll quickly rejoin the meeting. Yeah, I just lost my internet connection. Am I audible?
Yes, sir.
Yes, sir.
Wait, I'll share the screen again. Sorry for the inconvenience. Up till how much could you listen? Hello?
Yes, sir.
Yes, sir.
Yes, up till which question could you listen?
11th question, sir. Due to wall friction.
The wall friction you could listen, right? Okay,
Yes, sir.
okay, okay. Just a moment. 25. Yes. So I'll just repeat this question once. The wall friction of the retaining wall, option 1, decreases the active pressure but increases the passive pressure. Option 2, increases the active pressure but decreases the passive pressure. Option 3, decreases both the active and the passive pressures. And option 4, increases both the active and the passive pressures. Okay. All right. Next question. Okay. This is a multiple select question, so more than one answer might be correct. All right. Question is, the critical height of an unsupported vertical cut in cohesive soil is a function of. If anyone knows the formula, it will be very easy for him. The critical height of an unsupported vertical cut in cohesive soil is a function of. Your options are unit weight, cohesion, friction angle, or coefficient of active earth pressure. The PPT is visible, right? Clearly, you can see the options. Okay. Please let me know if anything is wrong in the audio or visuals. Okay. So, more than one option can be correct. The critical height of an unsupported vertical cut in cohesive soil is a function of. Your options are unit weight, cohesion, friction angle, or coefficient of active earth pressure. Coefficient of active earth pressure. Okay. Next question. The lateral earth pressure coefficient of a soil, Ka for active state, Kp for passive state, and K0 or Ko for at rest condition, compare as. What is the relationship between these three coefficients? Coefficient of active earth pressure, coefficient of passive earth pressure, and coefficient of earth pressure at rest. The first option is Ka more than Kp more than K0 or Ko. That is, coefficient of active earth pressure is more than the coefficient of passive earth pressure, which is further more than the coefficient of earth pressure at rest. Option 2, Kp more than K0 more than Ka. That is, coefficient of earth pressure at rest is more than the coefficient of active earth pressure, and coefficient of passive earth pressure is maximum. It is more than, also more than the coefficient of earth pressure at rest. Okay. Kp more than K0 more than Ka. Okay. Third option is K0 is more than Kp equals to Ka. That is, coefficient of active and coefficient of passive earth pressure both are equal, but the coefficient of earth pressure at rest is more than this value Kp and Ka. K0 is more than Kp equals to Ka. Last option is Kp less than K0 less than Ka. That is, the coefficient of active the coefficient of earth pressure at rest is more than the coefficient of passive earth pressure, and this coefficient of active earth pressure is maximum, it is more than the coefficient of earth pressure at rest. Okay, so you can write like this also, Ka more than K0 more than Kp. Instead of writing like this, Kp less than K0 less than Ka, also write in that way. Please write out this question very carefully, it is a very important relation. I'll repeat the question once. The lateral earth pressure coefficient of the soil, Ka for active state, Kp for passive state, and Ko for at rest condition compare as. That is, Ka is the coefficient of active earth pressure, Kp is the coefficient of passive earth pressure, and K0 is the coefficient of earth pressure at rest. How do they compare? The options are Ka is more than Kp is more than K0. Option 2, Kp more than K0 and K0 more than Ka. Option 3, K0 is more than Kp and Kp equals to Ka. And option 4, Kp is less than K0 and K0 is less than Ka. Alright, go to the next question. Okay, a true false statement. A tension crack usually develops because of negative pressure in the soil at the top of the wall. A tension crack usually develops because of negative pressure in the soil at the top of the wall. Is this statement true or false? Here wall means the retaining wall which contains the backfill, which supports the backfill soil. So we are talking about two things. One is the negative pressure because of which tension crack is formed, and another is the location, top portion of the soil in the near the wall, or the soil near the top portion of the wall. It is found. If both the parts are true, then only it will be true. If any one of the part is false, the entire statement will be false. I'll repeat the question once. A tension crack usually develops because of negative pressure in the soil at the top of the wall. Is this statement true or false? I hope it is clear. I'll go to the next question. Okay, this is a numerical, so please write down the data very carefully. The maximum vertical depth of excavation in meters that can be made in a saturated soft clay having cohesion 30 kilonewton per meter square and unit weight 20 kilonewton per meter cube is. So there is a saturated soft clay with cohesion 30 and unit weight 20. Okay, what is the maximum vertical depth of an excavation in meters that can be made? There is a vertical soil unsupported that can be made in this soil. So it is in meters. So the options are option 1, 3, option 2, 6, option 3, 4, option 4, 8. All the values are in meters. Okay. I'll repeat the question once. The maximum vertical depth of excavation in meters that can be made in a saturated soft clay having cohesion 30 kilonewton per meter square and unit weight 20 kilonewton per meter cube is 3 meters or 6 meters or 4 meters or 8 meters. Okay. Next question. Another numerical. If a uniform surcharge, that is a load of 120 kilonewton per meter square, is placed on the backfill with friction angle of 30 degree, the increase in active pressure in kilonewton per meter square is. So what is the increment in active pressure due to the surcharge load of 120 kilonewton per meter square, given that the backfill property, that is the friction angle, is 30 degree. The options are 30, 60, 40 and 80. All the values are in kilonewton per meter square. I'll repeat the question once. If a uniform surcharge of 120 kilonewton per meter square is placed on the backfill with friction angle of 30 degree, the increase in active pressure in kilonewton per meter square is. Your options are 30, 60, 40 or 80. Okay. From the next question onwards, there are no options. You have to solve it and tell me the answer. Go to the next question. Yes. Compute the intensities of active and passive earth pressure at a depth of 8 meter in dry cohesionless sand with phi equal to 30 degree and gamma equals to 18 kilonewton per meter cube. Phi is the angle of internal friction and gamma is the unit weight of the soil. Here it is cohesionless sand. The depth of the soil is 8 meter. I'll repeat the question once. Compute the intensities of active and passive earth pressure at a depth of 8 meter in dry cohesionless sand with phi equals to 30 degree and gamma equals to 18 kilonewton per meter cube. Okay. Next question. A rigid retaining wall 6 meter high is restrained from yielding. The backfill consists of cohesionless soil having phi equals to 26 degree and gamma equals to 19 kilonewton per meter cube. Compute the total earth pressure per meter length of the wall. So the wall is 6 meter high. The wall supports the backfill cohesionless soil. Phi equals to angle of friction equals 26 degree and gamma, that is the unit weight is 19 kilonewton per meter cube. compute the total earth pressure per meter length of the wall. Here the type of earth pressure you have to understand from the question itself. Which type of earth pressure you are told to find out. Okay, I'll repeat the question once. A rigid retaining wall 6 meter high is restrained from yielding. The backfill consists of cohesionless soil having phi equals to 26 degree and gamma equals to 19 kilonewton per meter cube. Compute the total earth pressure per meter length of the wall. Next question. Compute the intensity of passive earth pressure at a depth of 8 meter in a cohesionless sand with an angle of internal friction of 30 degree when the water rises to the ground level. Saturated unit weight of sand is 21 kilonewton per meter cube and unit weight of water is 9.81 kilonewton per meter cube. So you have to find out the passive pressure at a depth of 8 meter. Again, it's a cohesionless sand with an angle of friction of 30 degree, but the condition is the water has risen to the ground level. The saturated unit weight has been given 21 kilonewton per meter cube and the unit weight of water is gamma W is 9.81 kilonewton per meter cube. I'll repeat the question once. Compute the intensity of passive earth pressure at a depth of 8 meter in a cohesionless sand with an angle of internal friction of 30 degree when the water rises to the ground level. Saturated unit weight of sand is 21 kilonewton per meter cube and unit weight of water is 9.81 kilonewton per meter cube. Okay.
Excuse me, sir.
Yes.
Sir, in this question, weep hole is given or not given, sir?
No, weep hole is not given.
Okay.
If anything is not mentioned, weep hole is not given.
Okay,
Okay.
sir. Thank you.
Yeah. Yes, you can mute yourself. Okay. Next question, the last question. A vertical excavation was made in a clay deposit having unit weight of 22 kilonewton per meter cube. It caved in after the digging reached 4 meter depth. Caved in means it broke down. It failed. The excavation could not support itself. Okay, that's the meaning of caved in. After digging reached 4 meter depth. Assuming friction angle to be 0, determine the magnitude of cohesion. So here the depth of the excavation before caving in is given as 4 meter. This clay has a unit weight of 22 kilonewton per meter cube. Here friction angle is 0. This cohesionless soil, obviously it is clay. You have to find out the magnitude. Sorry, the friction angle is 0. It is a cohesive soil. It is clay, not cohesionless, cohesive soil. You have to find out the magnitude of cohesion in this clayey soil. Okay. I'll repeat the question once. A vertical excavation was made. Someone is joining now. Okay, who is joining now? Please stay in the meeting. I have already completed dictating the questions. I have given some time, around 15 minutes, for the people who have written down the questions for them to solve the questions. And after 15 minutes, I'll start discussing the answers. Okay. The last question is, a vertical excavation was made in a clay deposit having unit weight of 22 kilonewton per meter cube. It caved in after the digging reached 4-meter depth. Assuming the friction angle to be 0, determine the magnitude of cohesion. Okay, so it is almost 5:50 now. I'll start around 6:05. Okay, I'll start around 6:05. Okay, till then you can solve the questions at 6 o'clock. From 6 to 5 onwards, I'll start discussing the solutions and explaining the concepts behind the solutions. Whatever you have doubts, I explain. Okay. Am I audible? Am I audible? PPT visible?
Yes.
Okay, so I'll start discussing the answers. The first question was, if every point in the soil mass is on the verge of failure, soil is safe to be. What is the answer?
Plastic.
Plastic equilibrium. Yes, it is called plastic equilibrium. And the equation is that of a shear failure, sigma 1 equals to sigma 3 tan square alpha plus 2 c tan alpha, equation derived from the shear test, triaxial shear test. You can go through the YouTube videos of the previous sessions. This equation has been used in many sums. Alpha is what? Alpha is equals to 45. Is the failure plane angle 45 plus
45 plus 5 by 2.
5 by 2. Phi is the angle of internal friction. So this is the equation
5
of
by
the
2.
plastic equilibrium. And at this, in this condition, every point on a soil mass is on the verge of failure. Okay. For plastic equilibrium. Okay. Next question. Ratio of horizontal to the vertical stress. Just a minute. So the plastic equilibrium. Just a minute. The plastic equilibrium is this. I just yes. Okay. Ratio of the horizontal to the vertical stress. What is it called?
Coefficient of earth pressure.
Yes, coefficient of earth pressure. Because the horizontal stress is always a function of the vertical stress. This function is called the coefficient. So the ratio becomes like this. The coefficient of earth pressure. Right? So it is the coefficient of earth pressure. Okay. Next question is, when a rotating wall moves away from the backfill, the pressure developed is known as. What is the answer? Hello? Any answer?
Active, sir.
Active pressure.
Yes, yes, active pressure. This is the backfill. There is a wall over here. If it moves away like this, the pressure will decrease. Okay. This is the what is pressure at rest. Wall moves away from the backfill. This is the part that we call is P. Wall is moving away. This is the soil mass. Soil mass. It is active pressure on the soil. Please mute yourself. active pressure, right? So this question will also be easy, I guess. Passive earth pressure occurs when the retaining wall. What is the answer? Passive pressure occurs when the retaining
So
wall
what the part?
moves
C,
towards
sir.
Part of soil.
yes, moves towards the soil. Moves towards the soil. In this diagram, if this is the soil mass, so this part is the passive pressure. So it is moving towards the soil. If this here I'll draw once more. If this is the earth, this is the backfill. If this is the retaining wall. It moves towards here. It presses the soil against the backfill. This is the soil, and the soil experiences passive earth pressure. Okay, passive earth pressure. It is to be noted that this movement towards the wall is mainly in the field condition. It is because of any external condition, external circumstances. But in the case of active pressure, due to the soil pressure, lateral pressure, the backfill can move away from the soil. So passive is something which might not be witnessed in the field due to natural conditions. Okay, passive earth pressure occurs when the retaining wall moves towards the soil. I hope it is clear. Okay. Okay. Next question. Next question. With respect to the relative magnitudes of earth pressures, what is the answer over here?
C, sir.
Both of the
Yes, both of the above.
both of the above.
Yes, both of the above, because when there is a backfill and there is a retaining wall, when the wall is moving away from the soil, it is passive earth pressure. The soil will have least earth pressure, very less earth pressure. It is moving towards the backfill. It is called passive earth pressure. The soil will experience much more force, much more pressure due to the movement of the retaining wall. So active earth pressure will be minimum, yes. Passive earth pressure will be maximum, yes. This is P. Passive earth pressure, maximum, yes. So both of the above are correct statements. Okay. So with respect to the relative magnitudes of earth pressure, active earth pressure will be minimum and passive earth pressure will be maximum. Okay. I hope it is clear. Next question. Among the following, which among the following is considered while designing ordinary retaining walls? Any answer?
Passive earth pressure.
Passive earth pressure.
It is active, sir. Minimum.
Yes, the minimum pressure is active. Obviously, because when you are designing retaining walls, okay, we are concerned about the force that will be experienced on the wall by the backfill, isn't it? By the backfill. So force experienced by the backfill will move away from the retaining wall will move away from the backfill, isn't it? When you are designing retaining walls, we are designing it to support the soil. That means we are designing it. Please mute yourself. We are designing it to support the backfill. Okay, that means we are designing the retaining wall to withstand the pressure exerted on the wall by the backfill. So if you are considered about the if you are considering the pressure exerted by the backfill on the wall, due to that kind of pressure, the wall will move air from the backfill further, and that time the pressure experience will be active earth pressure. So while designing retaining walls, the active earth pressure is being considered while designing the retaining walls. Okay. Okay. Next question. Which of the following is not an assumption in the Rankine's earth pressure theory? What is the answer?
B, sir.
B. Soil is saturated and cohesive. It is wrong, right? You are saying it is not an assumption.
Yes.
Yes.
Yes, sir. It should be dry and questionless soil.
Yes. So soil is homogeneous, infinite, dry, and cohesionless, isn't it? That is the assumption in the Rankine's earth pressure theory. So ground surface is planar. Obviously, the ground surface we consider as plane. This is the backfill. This is the ground surface is plane, either horizontal or it can also be plane, but it's a plane surface, not rough. Retaining wall back is smooth and vertical. This back of retaining wall is vertical. It is smooth. There's no like roughness. Only this is wrong because it should be dry and cohesionless. Okay, because in case of cohesive soil, there is also a parameter of tension crack, which makes the thing complicated. So this is not an assumption. So not an assumption in the Rankine's earth pressure theory. The answer is soil is saturated and cohesive. The actual parameter to consider as an assumption is the soil will be homogeneous, dry, and cohesionless. Okay. Next question. Weep holes are provided in retaining walls for the following reason. What is the answer? Drainage.
Yeah.
Yes, okay. Okay, you can mute yourself. Okay. Yes, to provide drainage of the backfill because in saturated conditions, the backfill might exhibit swelling or shrinkage behavior which might exert pressure on the retaining wall. So, in order to drain the excess water, to let go of the pore pressure in the backfill, weep holes are provided in the retaining wall so that the excess water get drained out. Okay. Yes, good. The answer is weep holes are provided in retaining walls to provide drainage of backfill. Okay. Next question. For a cohesive backfill, the depth up to which the total net force will become zero is called. What is the answer? Yes.
It should be seen as, huh?
Yes. Are you not sure? You are asking.
No, I am sure, sir, but actually, ZDT is the depth of the tensile crack.
Yes.
It's
Tensile
also
crack.
called depth of the. It's also called depth of the negative pressure zone.
Yes. And double that zone is the height up to which it can support itself, right? So it
Yes,
is
sir.
called critical height or unsupported vertical height. Both are
Yes, sir.
correct.
It's also given in one of your question. Another two questions, and after two questions,
Yes,
in the
yes,
question itself, answer is there.
yes. Good observation. Okay.
Yes.
So the depth up to which total net force will become zero. That means if this is the pressure like this is the entire height of the retaining wall. Okay. Here it is negative pressure. Similarly, this height, if you consider over here, this height, this is another. This is Z0. This is also Z0. This is the tensile crack zone, tension crack zone, and up till this, that is 2Z0, this vertical excavation can support itself. Beyond which it will cave in or it will fail. Okay, it will start crumbling or failing. So this height is called the critical height or the unsupported vertical cut. It has a formula we will see in the next questions.
Sir, excuse me, sir.
Yes.
So I want to know from your side what is the alternative names for Z0?
Z0, tensile crack, tension crack depth, you can call it. Tension
Okay, sir.
crack
One
depth.
one is the depth of the tensile crack.
Yes.
The another one is it is a depth at which the pressure also zero. We can also call like that, right, sir?
No, depth of tension crack is Z0. This is the negative pressure depth.
No, sir.
Okay.
What I am
Yes.
saying is
Yes.
Z0 also called as a depth at which pressure is zero.
Depth at which pressure is zero, that means from the top. You are saying from the
Yeah,
top,
from the
right?
top.
Yes, from the
Yeah,
top, the depth at which pressure is zero because it starts from the negative till here it is zero. Okay,
yeah,
but this
yeah.
see this triangle you are talking about the pressure, isn't it?
Yes, sir.
But if
Yes,
we
sir.
see the pressure over here is zero, but the
Yeah.
soil is experiencing a force over here. Okay, that is equal to
Yes,
the
sir.
area of the triangle. Now this area of the
Yes.
triangle will be, what to say, it will be mitigated by the next area of the triangle, this area of the triangle, where it will experience a positive pressure. So here pressure is 0, and but this is the ultimate height at which it can sustain itself. So yes, you are right. From the top, that is from the ground surface, this is the depth of tension crack. The depth of tension crack from the ground surface up to this, the pressure is 0. That is, from ground surface till Z0, the pressure will be 0 at the depth of Z0. Okay.
Okay, sir.
Any confusion regarding this?
No confusion, sir.
Yes, yes.
Actually, I used to call them as a three alternative names.
Yes,
One
alternative
is
names, yes. But
one is
critical height and unsupported vertical cut are not alternative names for Z0.
yeah, that is different, sir. That is
Yes,
different.
yes, yes,
I am
yes.
not asking. I am not
Okay,
asking
you are
about
asking, you are
critical
asking
depth.
a different question about the tension
Only,
crack depth.
yeah, only
Okay, okay.
alternative names for Z0.
Alternate name for Z0. Yes, tension crack depth up to depth at which the total pressure is 0.
0, yeah.
Okay.
Yes, sir.
Here I have talked about the net force becomes 0. So
Yes,
here
sir.
I'm
I
talking about
understood, sir. Understood.
okay, na? Okay, good.
Understood, sir. No
Yeah.
confusion.
Okay, good. So I'll go to the next question now. Clear?
Yes, sir. You can go, sir.
Okay. Just a minute. Yes. In a soil, lateral pressure can never develop under this condition. Any answer?
Hope it is over consolidation, sir.
Not hope, it is correct.
Yes, sir.
It is correct. Over consolidation. Why? See, in the case of earthquake, there will be lateral pressure because of tectonic movements, isn't it? Earthquake will witness tectonic movements. There might be, there is a chance of lateral pressure being exhibited. In the case of swelling, also obviously, force will be present from the lateral sides, so lateral pressure will develop. And same goes for ice formation. The volume increases, right? When the ice is formed, the volume is increased. So it is a similar case with swelling. But over consolidation itself means the pressure is applied from the vertical, from the y-axis, the vertical axis. Okay. So in this case, we do not consider the generation or the application of lateral pressure. So lateral pressure can never develop under the condition of over consolidation. Okay.
Sir, can I ask a small practical question, sir?
Yes, yes.
For example, somewhere if you have a over consolidated soil, sir,
Yes.
when you excavate a trench or pit or whatever may be, then does it require any lateral support if there is no any lateral pressure? You are making a trench excavation in over consolidated soil.
Over consolidated soil. Yes.
Yeah, as per our discussion,
So
in this
over consolidated this process, this question and this process. Okay.
okay,
So during over consolidation, the process of over consolidation, lateral pressure won't be developed. But if the soil is being over consolidated and we are digging a trench in that soil, then everything will follow this kind of diagram, this kind of procedure, up till which the soil can support itself up till a depth of Z0. Okay,
okay, sir,
depending upon the
okay,
cohesive properties or the frictional properties of the soil. Here I
okay,
am talking about the
understood.
process of over
Okay, sir.
consolidation. Okay.
Right, sir.
Okay, good. Okay, so over consolidation will never see the generation of lateral pressure. Fine. Next question. The wall friction of the retaining wall. What is the answer? What does it do?
Option A, sir.
Increase the
No, someone is
Sir.
yes, someone else was saying. What were you saying? Increases.
My option is option A.
Yeah, your option I heard. Yes, your option is right. Option A is right. Decreases the active pressure. Who is saying option B or D is not right? Because simple thing. there is a backfill. I am not going into the mathematical formulation right now because I am saving it for the next class of this wall friction. If I can, I'll incorporate some mathematical formulation or some numericals in this wall friction. But right now I'll be saying only this, that if this wall is having friction in this surface, then if it goes towards the backfill, okay, then there the contact between the backfill and the wall will get enhanced. The contact between the backfill and the wall will get enhanced, and when it does, there is a condition of passive pressure. So that will increase. And when it's a case of active pressure, the wall is moving away from the backfill, the contact between the backfill and the wall back, it reduces. Okay, that is the case of active pressure. So yes, it is a general question. The wall friction, it decreases the active pressure and it increases the passive pressure. Okay. So who was saying increases? Is it clear why it is decreasing and how it is decreasing?
Yes.
Okay.
Sir, can you repeat it, sir, once, please?
See, friction, what does it do generally? It increases the strength, right? In any sort of materials. When you are talking about the wall friction, that is, there is certain amount of wall roughness. So when it moves towards the soil, the contact between the backfill and the wall, back of the wall, it enhances, isn't it? The contact between the wall and the backfill enhances. Like just a simple thing, you take a some part of clay in your hand, and you take a smooth plate, okay, smooth plate, and you try to compact the clay. And in the second case, you take a rough plate, try to compact the clay. Because of the roughness, clay or whatever kind of soil, because of the roughness, okay, the interlocking property of the particles in the soil will get enhanced because of the roughness which is the friction applied from the back of the wall. Because of the contact between the back of the wall and the backfill, that enhances the contact, and hence the pressure it increases. And that pressure it applies when during the passive pressure state, isn't it? The wall is moving towards the backfill. The opposite happens during the active pressure. When the wall is moving away from the backfill is losing the contact with the wall friction, if the wall has friction at all. Okay, so when the backfill is losing the wall friction, the initial pressure will decrease. Okay, because initially when the earth pressure at rest, when it is K0, suppose it is K0, okay, the wall is standing straight, the friction on the wall was providing some support to the backfill. If no roughness was there, then the value of K0, when it transferred into Ka, it would have been something, but when including the wall roughness, this Ka is happening, there is a much more decrease from K0 to Ka. Why? Because now the soil is losing the interlocking with the backfill when it is moving at the front or away from the backfill. Is it clear?
Yes, sir. Thank you, sir.
Yes. Okay. All right. Next question. Yes, this is a multiple select question. Critical height of an unsupported vertical cut in cohesive soil is a function of. What is the answer?
First, second, and fourth, sir.
First, second, and fourth. Okay.
And here my doubt is fourth one includes indirectly third
Yes,
also.
yes. So what will the answer be? Simple.
So in that case, all of them should be there.
Yes, all of them. Yes, because you see, HC is equals to what? 4C by gamma.
4C by gamma square root of Ka.
Square root of Ka, or if I write initially tan what? 45 plus pi by 2, right? Tan alpha.
Yes, sir.
45 plus pi by 2. This when modified and we incorporate the parameter of Ka, then we write like this. So if you say unit weight, yes. If you say cohesion, yes. If you say active pressure coefficient, that is also yes. And this is in turn dependent on this. And the entire HC is also dependent on this. So yes, everything interconnected. So all are correct answer. The critical height. So we can write in mathematically like this. Hc is a function of what? Is a function of cohesion, unit weight, phi, and Ka. Okay, so it's a function of unit weight, cohesion, friction angle, and coefficient of earth pressure. Clear? Coefficient of active
Yes,
earth
sir.
pressure.
Yes.
Yeah.
Yes,
Okay.
sir.
Okay. So in this scenario, I guess next question will be also very easy for you. The lateral earth pressure coefficient of the soil Ka active, Kp passive, K0 at rest condition will compare as, how will they compare?
Option B, sir.
Yes, option B. The coefficient of passive earth pressure is more than the coefficient of earth pressure at rest, and the coefficient of earth pressure at rest is further, it is more than the coefficient of active earth pressure, because when the when the retaining wall is moving towards the backfill soil, the condition is passive earth pressure, the earth pressure is increasing and it is moving away from the soil, the earth pressure, the pressure on the backfill is decreasing. Okay, good. Next question. Tension crack develops because of negative pressure. I think I've already discussed this part. So, what is the answer?
True, sir.
True, yes. On the top part of the wall, right? I've already discussed this diagram like this. So this is the top part of the wall. Here, negative pressure is developed when the soil is cohesive. Specifically, here it is not being mentioned, but you have to take it for like you have to assume it the soil is cohesive, and in the top part of the wall, negative pressure is developed, and hence tension crack develops. So it is true. Okay. Okay. The maximum vertical depth of excavation in meters that can be made in a saturated soft clay having cohesion 30 kN per meter square and unit weight 20 kN per meter cube. What is the answer?
6 meters, sir.
6 meters.
How do you solve this? First of all, you see maximum vertical depth, that is the unsupported height, H equals to what? 4c by gamma root Ka, and I know Ka formula is 1 minus sine phi divided by 1 plus sine phi. Okay. Saturated soft clay I have mentioned, that is phi is equal to 0. So this becomes equals to 1. So it will basically 4 into C divided by gamma. 4 into 30, 120. 120 divided by 20, it gives us 6 meters. So up till 6 meter height, the excavation can sustain itself. Okay. Having this condition, that is, it is a saturated soft clay, and cohesion and unit weight is these 30 and 20. Okay. Next question. If a uniform surcharge of 120 kilonewton per meter square is placed on the backfill with friction angle of 30 degrees, the increase in active pressure in kilonewton per meter square is. What is the answer?
40 kPa, sir.
40 kilonewton per meter square or 40 kPa. Yes. Again here we are going to find out the value of Ka will be how much? Friction angle 30 degree, that is 1 minus sine phi, that is by 1 plus sine phi. It will be how much? 1 by 3, right? Half by 3 by 2. It will be 1 by 3. Yes, 1 by 3. Now uniform surcharge sigma is given, increase in active pressure. Active pressure Pa is how much? Ka into sigma, it is 1 by 3 into 120 is equals to 40 kilopascal. Simple. simple formula we are using over here to find out the increase in active pressure. There is increase in lateral pressure when the uniform surcharge is placed on the backfill having friction angle 30 degree. Okay. Next question. Yes, compute the intensities of active and passive earth pressure at a depth of 8 meter in dry cohesionless sand with phi equals to 30 degree and gamma equals to 18 kilonewton per meter cube. Has anyone solved it?
Yes, sir, I did,
Yes,
sir.
sir.
Yes, what is the answer of active and passive earth pressures?
Active
And
48 kilopascal.
Active how much?
48 kilopascal.
Yes, and passive pressure?
432 kilopascal. 9
Yes,
times.
yes, very good, very good. So we can, I'm not solving using the 9 times you said because I'll be elaborating it for people to understand. So first we'll be finding like this k1 minus sine phi by 1 plus sine phi, that will be equals to 30 degree, that is 1 by 3, and kp will be how much? 1 by ka, right? 1 by ka equals to 3. Okay, so using this I'll first find out the intensity of active earth pressure, that is Ka gamma into H, that is 1 by 3 into 18 is 6 into 8 is 48. What will be the unit? What will be the unit? Kilonewton per meter square, right? Or kilopascal. And what is the answer of passive pressure? Who said the answer of passive pressure?
432, sir.
Yes, 432. Kp into gamma into H, that is 9 times of this. And just multiply this with 9. You'll get Kp is 3, is 432, 77 into 30 plus 7, 43 kilopascal. So, this formula will be very easy to remember. A fraction of the vertical pressure is the horizontal pressure, isn't it? Again here, a fraction of the vertical pressure is the horizontal pressure. The only thing, this is a very interesting formula, and this, the reciprocal of this is the passive earth pressure. If you remember how to find out the coefficient, rest will be a cakewalk. Okay. Okay. Next question. Rigid retaining wall 6 meter high is restrained from yielding. The backfill consists of cohesionless soil having phi 26 and gamma 19 kilonewton per meter. Compute the total earth pressure per meter length of the wall. Anyone has solved it?
Yes, sir. 192 kilonewtons.
Yes, 192, 192 point something. Yes. So I have said here that is restrained from yielding, right? So it is earth pressure active or passive or at rest?
Rest conditions, sir.
Rest condition. So the value of coefficient will be how much? What is the formula? What is the formula for the coefficient of earth pressure at rest?
1 minus sine phi.
Yes, just the numerator in the case of active, 1 minus sine phi, and that will give you a value of sine phi 26 degree, I think 0 0.5616, 0 0.5616, isn't it? Now I have told you to find out earth pressure per meter length of wall. So this is actually the force condition. I'll say half K0 gamma H square, isn't it? Half K0 gamma H square. So here half K0 is this, gamma is 19, H is 6 meter. You put everything, you'll get a value of around 192.1, something like this, in terms of kilonewton per meter. Yes, kilonewton per meter. Whenever it has been told per meter length of the wall, it is force per meter length of the wall. Total earth pressure per meter length, that is not kilonewton per meter square, that is kilonewton per meter. Okay, so you have to use this formula for the finding out the force. Clear?
Yes, sir.
Next question. Compute the intensity of passive work pressure at a depth of 8 meter in a cohesionless sand with an angle of inclination 30 degree when water rises to the ground level. Saturated phase 21, unit of water is 9.81. Have you solved this question?
Yes, sir.
Yes. What is your answer?
1388.16 kilonewtons. Kilonewton per meter. Sorry, sir. You asked pressure, right? It is 347.04.
Yes, not the, yes, 347.04. Very good. Very good.
Yes, sir.
So what is the first step over here? We need to find out the value of Kp, that is coefficient of passive earth pressure. This is 1 minus, this is 1 plus sine phi, 1 minus sine phi. 30 degree again, it is equal to 3. Yes, 3. So saturated unit weight is given, and we know in the case of earth pressure, we first calculate the submerged unit weight, submerged pressure, and then the pressure of water. Separately we do. So submerged unit weight, gamma submerged will be what? Gamma sat minus gamma depth. That is 21 minus 9.81. That will be equal to how much? Approximately 11.19 kilonewton per meter cube. Isn't it? Gamma submerged. Now, time for the passive earth pressure. Passive earth pressure will be equal to how much? Kp gamma for the soil, gamma submerged H plus gamma W into H. Right? Not the saturated part, but the submerged part plus the water. So Kp is 3, gamma submerged is how much? 11.19, H is 8, and gamma W is 9.81. You get a value of approximately 347.04 exactly. Okay, kilonewton per meter square. Okay, 347.04. So first, in this case, in case of saturated soil, for lateral earth pressure, we first consider the submerged part and take the water portion separately. Okay. All right. Last question. A vertical excavation was made in a clay deposit having unit weight of 22. It caved in after the digging reached 4 meter depth. Assuming friction angle to be 0, determine the magnitude of cohesion. Have you solved this question?
Yes, sir.
Yes. What is the value of cohesion?
Cohesion is equal to 22 kilopascals.
Yes, 22 kilopascal. How to solve this question? You first find out the value of Ka, isn't it? Ka. Friction angle is 0. So if we put the same formula sine phi by 1 minus 1 plus sine phi, phi is equal to 0, it gives us a value of 1, isn't it? So the formula for the active earth pressure, that is Pa, is equals to, when there is a cohesive soil and taking into consideration the tension crack also, it is Ka gamma H minus 2C root over of Ka, isn't it? This is the formula, right, for finding out the pressure, active pressure. Now this is equals to how much? It has been said 4 meter depth. Okay, so H is not given, so K is 1, gamma is 22. So I can write over here like this: gamma is 22, Z H is equal to Z minus Ka is 1, so it is 2C. It is 2C. Now at a depth of 4 meter, after reaching 4 meter depth, that is Z equals to 4 meter. At Z equals to 4 meter, the pressure will be how much? Pressure will be equal to 0. Now 22Z minus 2C equal to 0, or at Z equal to Z0, P equal to 0, yes, or C equal to Z0 will be equal to how much? Z0 equal to will be C by 11, right? C by 11. Now, yes. So at this, not 4 meter, sorry, at this height, the pressure is equal to 0. Okay. Now, what is 4 meter? 4 meter is the height at which it can sustain itself. That is 2z0 is equals to 4 meter. 2z0 equals to 4 meter. So 2c by 11 equals to 2c by 11 equals to 4 meter, or c, not 4 meter, not right here. C equals to, yes, c equals to 22 kilopascal. Is it clear?
Yes, sir.
Yes. So what did I do first? What needs to be done first? Find out the coefficient of active pressure, form the equation, write the equation in terms of Z, because you don't know at what value the pressure is equal to 0. Okay, in terms of Z and C. Now the pressure will be equal to 0 at Z0. Let Z equal to Z0. So Z0 will be in terms of C. Now it has been said that if every after taking 4 meter, that is the critical height is 4 meter. That means 2z0 equals to 4 meter. So from this equation you can find out the value of cohesion easily. Cohesion will be 22 kilopascal. Okay. All right. Okay. Any question? Any doubt regarding this session?
Sir, I think earlier you have clarified me the doubt of that wall friction question.
Okay, it is clear, right? So there is no more doubt regarding that question.
Yeah, theoretically it was clear,
Yes.
but using a formula also, can you get the answer
Yes,
for
using
this?
formula, I will be incorporating that formula in the next class, because everything
Next
I
class
cannot.
you can tell me, sir. No
Yes,
problem.
in the next class, because the earth pressure theory will be continuing for 2 sessions, so everything I cannot
Okay.
include in the one class. Also, if you want to see, you can follow some standard books. There are some standard books of soil mechanics. Which book do you follow?
Okay, sir. Done, sir.
No, which book do you follow? I'm asking you.
So
For soil
I follow many of the books, sir. Actually, I refer the Das book, in which there was a tabular column between
uh,
the Rankins theory as well as Coulomb's theory.
Okay, you can follow soil mechanics books, Indian authors like B.C. Punya and Gopal Ranjan Rao. Okay,
Sure, sir. I have referred that also.
okay. So you can see in the next class, I will try to, because I have to incorporate many other problems also. Okay, I will
Okay,
try
sir.
to
Okay, sir.
incorporate
At the end of the unit also you can tell me, sir. No problem.
yes, I will try to incorporate the wall friction part. That is the
Yes,
numerical
sir.
part
Only
of wall
wall friction.
friction. Okay, I will try
Yes,
to
sir.
incorporate. Okay,
Thank you, sir.
thank
Thank
you
you
for
very
this
much,
the
sir.
class.
Thank you,
Okay,
sir.
yeah. Okay, bye.